Okay, so in this first example, using scale factors for two-dimensional and three-dimensional objects, we're looking at a rectangle. So it's a two-dimensional object. Does that make sense? It's a square on a paper, a rectangle on a paper, that's two-dimensional. What makes something three-dimensional? Like if you can hold the object, right? And there's three dimensions to it. Okay, so we're going to go rectangle here. It's a 5 by 9 centimeter rectangle. So what's the area of that rectangle? This length times width of a rectangle is 45 centimeters squared, right? Using a scale factor of 2, so what does that even mean? A scale factor of 2. It means I'm going to double the size of the rectangle. So I'm going to blow it up, and now this wall would be 10 centimeters, and then this would be 18. So there's the new dimensions. So what's the area of this rectangle? So what's 10 times 18? 180 centimeters squared. Okay, so what do you notice? This area compared to this area, I can tell you that it's not doubled. So what is the relationship? Can anybody get me a relationship from 45 to 180? How much times bigger did it end up? 4 times bigger. Okay, so I'm going to go linear. Scale factor was 2. The area scale factor is 4. So where did that come from? I had to take the linear and square it. Okay, because I'm going into area, I'm squaring stuff. Okay, so whatever you get, that's what you're doing. You're squaring it. Okay, so let's try another one. So a computer screen measures this. So that's a computer screen. And I'm going to blow it up to put it onto a projector, right? So it's going to get bigger on the wall. When I project my computer to you guys, right, it gets bigger. Then I know from reading the area of the projector. Okay, so here's what I want you to do on this question. Get me the area of my computer. What's my computer screen area? So can you give me, so this is the computer and this is the projector. Can you get me the area of my computer screen? So give me a length times a width. Okay, so here's my next question. How many times bigger is the area? How many times bigger is that area? This to this, how many times bigger is it? I got 3.76 times bigger. Is that what you got? What am I doing? I did this divided by that to see how many times bigger it was. Okay, so here's my question now. If I know the area scale factor, how can I get the linear scale factor? Okay, so I'm going to go back here. Here I had the linear scale factor, and I squared it to get the area scale factor. What could I do if I have the area scale factor and want to get to this linear? What would you do instead? Because these are opposite of these, right? We went from linear to area, now I'm going from area to linear. So what are you going to do instead? You're going to square root, because here I squared to get that, so I'm going to square root to get this. So the sides need to be 1.94 times bigger. The area is this much bigger, so the sides are this much bigger. Okay, so what does 55 turn into? So if I 55 and I make 1.94 times bigger, so I'm timesing 106.7 centimeters would be that dimension. And 67.9 centimeters on that one. Okay, cube. What is a cube? So, like a Rubik's Cube, 8 by 8 by 8. So what is the volume of that shape? So how do you get a volume of a cube? You do length times width times height. 8 times 8 times 8. Using a scale factor of a half. So I need to make all the dimensions a half. So my new cube is going to have a 4 by a 4 by a 4 on it, because I'm halving all of the dimensions. Okay, so I need you to think about this. The sides were all half. The volume, that's not half. So what is going on between these two numbers? What is this in compared to this? Okay, it's not half. The sides were half, but this isn't half of that. Can anybody get me a number between them? What proportion is between them? Okay, I'm going to show you something on your calculator. I'm going to do this divided by this. And I'm going to get 125 as a decimal, 0.125. There's a button on your calculator right here that has fractions, and it switches it to an eighth. Does everybody find that button? Okay, so here's my conclusion. The scale factor of the linear means the sides. Oh, you have a different thing.
Yeah.
Okay, so linear scale factor is a half. Linear means sides. And the volume scale factor was 1/8. So the sides changed by a half, but the volume changed by 1/8. What is going on? Do we have some kind of relationship between that and that? So the volume scale factor is the linear scale factor cubed. To go to area, we squared it. To go between volumes, we would have to cube the number. Do you know what cube means? 1/2 times 1/2 times 1/2 makes 1/8. Right? Because 1 times 1 times 1 on the top, 2 times 2 times 2 on the bottom. Okay, a square has a side of 6 centimeters. There's a square, it's 6 centimeters, and we need to enlarge it so that its length, side or height or whatever, is now 15. How many times larger is the area? Okay, I'm not going to calculate the area. Here's what I'm going to do. Give me a number between 6 and 15. How many times bigger? So give me a division there. What's 15 divided by 6? Did you get that it's 2.5 times bigger? So I did 15 divided by 6. So the sides are 2.5 times bigger. So tell me, how much bigger is the area going to be? So what am I going to do? What do you do for area? You square it. So this area is going to end up being 6.25 times more. Do you want to test our theory? Should we try it? I'm going to try this. So the area of this was 36. The area of this is 225. If you divide that, does it give us 6.25? Yep, it does. Okay, what if I turned this into a cube and tried the volume? So in other words, if there was a 6 by 6 by 6 cube and now there's a 15 by 15 by 15 cube, how much bigger would the volume be? So what am I doing? Volume scale factor would be the linear number cubed. The linear number cubed. So this is how much bigger the area got, and this is how much bigger the volume would get. Okay, last question. An object is 40 millimeters tall and it has a volume of this. It's enlarged by 120 times. How many times larger is the area? So the area scale factor. If we enlarge by 120, our area will enlarge by 120 squared. It'll be that much times bigger. And the volume scale factor would be 120 cubed. So here's one more question on this. I'm going to add on. What is the volume of the enlarged object? What's the volume of enlarged object? So what would you do to get that answer? I have the volume of the original, and I'm going to increase the object's volume that much times bigger. So I'm going to times. So that would be the volume of the object at the end. Okay, can you find a blank page like in all the stuff I've given you? Okay, so if you want to go from a linear square or scale factor to an area scale factor, you would do the linear scale factor squared. If you want to reverse that, if you want to go from an area to a linear, if you are in area and you want to go to the linear sides, what do you think you're going to do? What's the reverse of that? Square root. Okay, so that's working between area and linear. So what do I do if I'm going from a linear to a volume? You're going to do a cube of the linear. And what do you think you're going to do if you have a volume scale and you want to figure out what the sides are doing? What do you think you do backwards there? You need to do a cubed root. So my question is, do you know where that button would be on your calculator? Can everybody figure out what this cubed root of 27 would be? So if the volume is 27 times bigger, what's going on with the sides? Where's that button? Where's the cubed root button on your calculator?